Okay, I believe by now we have become familiar with geometric series. Okay, so what we want to try to do is that we want to try to use that understanding that we obtained from geometric series to try to come up with a geometric power series expression for a given function. Okay, so just remind ourselves, okay, to remind ourselves something that is if you have a geometric series that's in this form. Okay, let's say you have that is expressed in the form of 1 over 1 minus r. Okay, and since I'm dealing with a function, I'm just going to replace or substitute where there's r, I'll use x. So this would be 1 minus x, like that. So this here is like I had a function. I express in terms of a geometric series. Okay, it appears like that. Okay, because I'm just following that format. Okay, so it's more like I'm given this function, I want to write it in this form. And what do I mean? What you have to pay attention to is the arrangement that you have on the denominator as well as the numerator in some cases, of which the numerator, for example, if you had 1, let me not 1, let me say 2 over 1 minus 1 minus x, like that. So what it simply means here is that I can see write this as 2 multiplied by 1 over 1 minus what? 1 minus x. What you are trying to do is that you want to try to write this that we have in terms of what? In terms of that, or appearing like that. Okay, then we have a geometric series. Okay, expression of the given function. But from that geometric series expression of the given function, want to write it in terms of a power series. So how do you write it in terms of the power series? You just look at what you have right here. Okay, you don't include the negative sign because the negative sign just comes with the expression itself. Okay, unless if maybe you had something like 1 plus 2, like that on the denominator, not 2 but x, yeah, on the denominator, such that this one you have to write it in terms of what? In terms of a minus, meaning it's going to be what? 1 over 1 minus, open bracket, minus x. What you are writing and what you had is not supposed to be different. They are going to be different in terms of appearance, but the meaning is literally the same. Okay, so if you have this here, if you want to write it in terms of a power series, I'm just going to write, okay, um, let's say from n is equals to 0 to infinity, I have my 2 this side. Then what do I have on x there? You see just x itself. Okay, you write it with the coefficient in simple terms. Then I raise this to what? I raise that to n, and that's simply the geometric power series of the function that I'm given. That's in the form 2 over 1 minus what? 1 minus x. So this will make more sense if we do more examples. Let's try to pick some few questions. We try to come up with a geometric power series expression for that given function. So it doesn't always come easy. Okay, you have to do some factoring sometimes. Yeah, so let's say you have 1 over 4 minus x. So when you just look at what you are given, when you realize what you are given, it's important to also know that you are supposed to write it in the form 1 over 1 minus x. So it's your duty now to see, okay, how am I going to come up with this? All right, how am I going to come up with this from that? Okay, so what it means here is that, okay, I have a 4 here. Okay, where there is a 4, I'm supposed to have a 1. What do? I'll just factor out, or in other words, since 4, there's nothing that is common between this one and that one apart from 1. I'm just going to force the 4 to come out of what I have. It's more like, let's say this is in terms of brackets there. Okay, so it will be something like 1 over, I'm going to have 4, open bracket, I have 1 minus x of what? X over 4. So you are allowed to do anything as long as you don't change the meaning, because if I distribute the 4 inside the brackets there, what I'm going to get is still what I have here. So whatever you do, just make sure to say, when you try to reverse it, it will give you the main function, the first function that you were given. Okay, so now this can be written in the form 1 over 4 multiplied by 1 over 1 minus x over 4. Okay, so what do I write? I'll say, okay, from, let's say n is equals to 0 to infinity. Okay, I'll first of all put my 1 over 4 in front here. Okay, then I look at what I have here. I pick x together with its coefficient, of which that is going to be what? My x over my x over 4, which is more like x multiplied by 1 over 4, then to the power n. And this simply happens to be the geometric power series expression for this function that we are given right here. So just make sure to say, as you break down what you have, you don't change the meaning. And in this case, this is centered at 0. So what we also need to understand is that if you have 1 over, let's say 1 minus, so this is supposed to be x minus c. This is how it's supposed to appear initially, but because I'm centered at 0, then I don't have to bother about the 0 there. I'll just break it down the way it is. Unless if we try to do some questions that have, that are centered at some point other than 0. Okay, so that's how you come up with geometric power series expression of that question. So let's say let's try to look at another example. Let's say you're given your function f of x is equals to 1 over 2 plus x. Okay, I believe for this one we already have a picture of how it's going to look. Let's try this. Let's try to see. This would be from n is equals to 0 to infinity. Since I have a 2, I'll have like 1 over 2. Okay, I have like 1 over 2 there. Then I'm going to have x over 2 to the power n. But because I have a minus here, I have a plus there, meaning this is going to be a minus. Okay, so let's try to see. So remember to say this is supposed to be in the form 1 over 1 1 minus x. Okay, so what does this now become? So this becomes 1 over, remember to say we can factor out the 2, or maybe before I do that, I can write this as my 2 minus x there. It's still one and the same thing. So now we can say this is going to be 1 over, I'll say 2 open bracket, I'll have 1 1 minus x, like that, over what? Over 2. Whatever we do, we don't change the meaning. So now this can be written in a much desirable way, such as 1 over 2 multiplied by 1 minus x over what? Over 2 there. And that happens to be, you're going to say 1 over 2. So you're going to write this part. That would be what? Minus x over 2. You raise it to the n, which happens to the what? To be the geometric power series expression for that function that we are given, which is the same as that one. So even just by looking, when you do a lot of questions, even just by looking at what you have as a function, it's very easy to conclude just here to say, okay, this is going to appear like that. But of course, if it's an assessment, you have to show your work. But at least if you already have a picture of how everything appears at the end, it makes you solving that question or coming up with a geometric power series a lot of fun, because you know where you're supposed to end. You're not just breaking down what you have without having directions in simple terms. Okay, so let's try to look at perhaps what I would call a last question on this part. So let's try to use something that's a bit different. So let's say we are given our f of x equals to, so the numerator is not always 1. I've been using 1 for the first example and the second example. Let me try to use one that has something other than 1. So we have 3 over 4 plus x. Okay, so I think here I already have a picture of how it's going to appear. This would be more like 3 over 4. Okay, that would be infinity from n is equals to 0, and that is going to be minus x over what? Over 4 to the n. Let's try to see if that's the same. So here, always remember this is supposed to be 1 over 1 minus x, like that, and it is centered at 0. But I don't even have to say, I don't even have to bother myself to remember 0 anyways, because I'm supposed to say x minus c, of which is x minus 0, which is still remains to be what? To be x, and I'll just let it slide for now at least. But when I try to look at something else that is centered at some value other than 0, of course a positive value or even a negative value, we'll try to take that into consideration. Yeah, so this, we're trying to write it in this form. So the first thing that I would want to do is that let me try to take care of the sign there. This will be 4 minus x, like that. So what happens here is that I have to knock out the 3 on the numerator, and I also have to knock out the 4 there so that it becomes 1. So this would be 3 over 4 multiplied by, here instead of having 3 I have 1 divided by, so here I'll have 1, okay, 1 minus x over what? Over 4. Key thing, don't change the meaning. Okay, you can write whatever that you want, but don't change the meaning. When you expand again, it's supposed to give you the initial function that you had. So this happens to be 3 over 4 in terms of a power series expression, of course from a geometric series. That would be from n is equals to 0 to infinity there. Okay, that would be minus x over 4. We take it the way it is, the power n, we just take it the way it is there. And this happens to be the geometric power series expression for the function, of course centered at what? Centered at 0. And that's how you take care of such questions. In case you have not subscribed to the channel, please do so. Leave your thoughts in the comment section. Please subscribe and ring the notification bell so that at least you don't lose out each time we upload new videos. Thank you very much for watching.